Configuring the display of layers. Once all of the ecos have been executed, the components and nets will appear in the PCB design space to the right of the board outline, as shown in this image. Before you start positioning the components on the board, you need to configure certain PCB design space and board settings such as the layers, the grid, and design rules. Your view of your board is a bird's eye view, looking down the Z-axis into the board from the above. The PCB editor is a layer design environment. The objects you place on signal layers become copper when the board is fabricated. The strings you place on the overlay layers are silk screened onto the board surface, and the notes you place onto the mechanical layers become instructions on the assembly drawing that you point. You design the board looking down into this stack of layers, placing components on the top and bottom sides of the board, such as top layer or bottom layer, and other design objects on the copper, overlay, mask, and mechanical layers as you build up the design. As well as the layers used to fabricate the board, which include signal, power plane, mask, and silkscreen layers, the PCB editor also supports numerous other than non-electrical layers. The layers are often grouped in the following way. We have electrical layers that includes 32 signal layers and 16 internal power plane layers. Then we also have component layers, layers used in the design of the components including overlay, silkscreen, solder, and paste layers. Now, if an object is placed in a component footprint on one of these layers in the library editor, when the component is flipped from the top side to the bottom side of the board, all objects detected on a component layer are flipped to their partner component layer. Now, this includes objects on user-defined component layers pairs. Next, we have mechanical layers. Mechanical layers, the software supports unlimited general-purpose mechanical layers which are used for design tasks such as dimensions, fabrication details, assembly instructions, and so on. Then we have other layers. These include keep-out layer, used to define keep-outs that apply on all copper layers. We also have multi-layer, used for objects present on all signal layers such as pads and vias. We also have drilling drawing layer, used to place drilling information such as drill table, and the drill guide layer, used to display markers that indicate drill locations and sizes. The copper layers are added and removed from the design in the layer stack, which is discussed, and all other layers are enabled and configured in the View Configuration panel.